Hello, in this video I'm going to show you how to make a simple console-based version of Connect 4. This is going to be a grid-based game, very simple. There isn't going to be any win checking for the fours in a row. It's just going to kind of just allow you to play the game, and you have to spot when somebody's won or not. And if you follow along with this, you'll be in a good position to do the submarine game, which is going to come after this. It's very similar. It's kind of like a stripped-down version of Battleship. So let's pop over here to like what Connect 4 actually looks like. And so this is the game where you drop in the checkers from the top. And the way we're going to model this is using a two-dimensional array. And a two-dimensional array is just a grid of values. It is exactly like what we did in Pico 8 using Lua. However, Lua was actually kind of clunky in terms of making grid structures. You had to make a list and then add lists to the list, and then that would give you a grid. But there's actually a grid data structure built right into C#, and that is the two-dimensional array. So it's rather than an array with one index, it's an array with two indexes or two indices, and that allows you to have a row index and a column index and plot stuff on a grid. So let's go over to Visual Studio here. I have created a new project called Connect 4. It's a little console app. So inside of my class, let me add the variables that I'm going to need for this game. So if I want to have a board, like what am I going to use for my symbols if this is console based? Well, I'll use like X's and O's and for the different pieces, and if there's nothing in a square, I'll have it be a space. So it'll be a space or an X or an O. So those are all characters. So I'll have a two-dimensional array of characters. So what's the symbol for an array of characters? Just a regular old array? Well, you have to say I want a character array. The square brackets mean I want an array. Now to specify that it's a two-dimensional array, you put in a comma between inside the square brackets, and that indicates that there's like one index here and one index here. So we've got a two-dimensional array. That's a one-dimensional array. That's a two-dimensional array of characters. And then we've got to give our array a name, and I'm going to call it board. And then we have to actually allocate it. We've got to create that space. Carve out the memory for that. So for that we use the new operator, and then what is that going to be equal to? It's going to be equal to a new character array that's going to have two dimensions. And what do I specify the dimensions? I'll make it 8 and 7. So I'm making a two-dimensional array of characters called board, and then I'm allocating an 8x7 array of characters. So it'll be 8 wide and 7 tall. This will be like our X dimension, and that'll be our Y dimension. And we'll also need a character to keep track of whose turn it is. So I'm going to make a character called turn, and I'm going to set it equal to X. Now for characters, you use a single quotation mark. That means one letter. If I put in double quotation marks, that's not going to work. Double quotation marks means this is a series of one or more characters followed by a zero, a null terminator, which indicates the end of the string. So a single character is just indicated inside of the single quotation marks. Okay. All right. Well, let me make a let me do the stuff that we always need to do when we're going to make a console app of any complexity. Let's make a run function. I'm going to make a function called run that is spelled correctly, and then in my main function I'm going to say program p equals new program, and then let's run that program. Okay, so that's going to jump down to our run function. And the reason we have to do this thing with program p equals new program and then call the program's run function, is because main is static. And that creates problems because static functions can only call other static functions, and we don't want to make all our functions static. So that's the trick right there. Make a program and call its run function. So that's where our game code's going to go. Game logic. Game code goes here. Okay. Now let's make a function to set the board to all spaces. I'll call that function clear board. And what it's going to do is it's going to go over all the rows and all the columns of the board and set them all to be a space. So a space means there's like nothing in there. So just like in Pico 8 and Lua, we would use a for loop for this. Now the syntax is a little bit different in C Sharp, but if you have Visual Studio, it's actually very easy. Just type FOR and hit tab twice, and Visual Studio will make out the skeleton of a for loop for you. So how many times? So we're going to need 2 for loops, one to go across the rows and one to go across the columns. So I'll make my inner for loop J, and my outer for loop will be I. So let's say for maybe I, this will be my X coordinate here, and that'll be my J coordinate. So this inner loop is going to run 8 times because it's inside of a for loop that runs 8 times. So so this one, the J will be going down the columns, and this will be going, the outer one will be going across the rows. So now let me set the board at that index to be a space. So how do I do that? Well, again, it's the square brackets, and I separate the indexes with a comma. So this is the board at IJ equals a space inside of single quotation marks. So this says put a space in the board at column I, row J. Like this is your X and your Y. So that is all Clear Board has to do, actually. That's it. So all we're doing is covering every possible combination of row and column and setting it equal to a space. Let me make a function now that draws the board. This will be very similar. We might have to make some little adjustments though. So I'll maybe make a function called draw the board. And so again, what we're going to do now is go down all the rows and all the columns. So let's just stub out 2 for loops here, for loop inside of a for loop. And we've got to be kind of careful because this we want to be going across. This is like we want this to be our X coordinate and this to be our Y coordinate. Normally it wouldn't matter. I'm going to even put a note here, X, and then, no wait, this is our Y coordinate, and this is our X coordinate, because we have to print out stuff like a typewriter going across, drop down, go across, drop down, go across. We can't draw stuff in vertical stripes. We have to draw stuff in horizontal stripes. So let me make, since we know the inner loop is going to be our X and the outer loop is going to be our Y, maybe I'll call this like the outer one J and the inner one I. And how tall is our board? It's 7 tall. How wide is it? It's 8 wide. And now what I'm going to do is write out the value in the array at that IJ coordinate. So I'll say console.write, and this is write, not write line. Right? I just want to print out the single character. I don't want a carriage return after this. So I'll print out the board at IJ. And then once I've printed out the entire row going, or the entire row going across, now I need to print out a carriage return to drop down. So I'm just going to have a console.writeLine with nothing in it. Now, what was that trick I just did? If you hit CW tab tab, that expands to console.writeLine. So what this is going to do is it's going to write out the first row of the board and then print out a carriage return, then print out the second row of the board, then the third row until the whole thing's been printed out. And then let's print out like a legend or something. You know, just print out a like a bar below the board or something. I don't know. Just some yeah. What do they call that? Like a map legend or something. Okay. So let me just print out 8 spaces, 8 little dashes or something just to indicate the bottom of the board. Console.write. And then I'll print out a new line, and then I'll print out the column names or the column numbers or something. So how will I do that? So I want to print out maybe the numbers 0 to 8. Okay, so no, wait. If I print out I, what's that going to do? I don't think it's going to print out what I want. What if I do 0? Let's just see if that works. This is the character 0 plus I. So it'll print out a 0, a 1, the character 0, character 1, character 2. Let's just see if that works. And you'll see, so that's how we're going to, when you want to drop a checker in a column, you're going to have to give the number of the column you want to drop the checker into. So that's why we want to see the legend at the bottom. So let's just try that. Draw board, and then I'll just say console.read key, just to hold the console open. And let's run it and see what that looks like. That did not work. Oh, you know what? That's the wrong game. Huh. That's the submarine game. Set a startup project. No, did not work. All right, hang on. Let me figure out what so obviously there's something wrong with my scheme down there to print out the numbers. It's printing out like the ASCII character codes. What if I just print out the number? Oh, okay, that works. Great. So I made it more complicated than it needed to be. All right. So now let's make a function that drops a checker. So we've cleared the board. Now we can draw the board, and well, let me just kind of go to this is the bottom of draw board right there. I'll just kind of freeze frame that for a second, just so you can, if you need to pause your video, you've got a chance to do that. All right. So now what we need to do is drop a make a function to drop a checker. So let's give ourselves some space here. I'll do that. It doesn't matter where you put your functions in; they can go in any order. And maybe this function takes the column to drop the checker into. Okay. So what we're going to do is start at the bottom of the column. So this is going to be 0, 1, 2, 3, 4, 5. If our thing is 6 tall, or maybe we'll have to go see how far. I think we made our thing 7 tall. So it's going to be, 0, 1, 2, 3, 4, 5, 6. So 6 would be the biggest index because the indexes start at 0. So what we're actually going to do is, rather than kind of model the checker coming down from the top, we're going to model it coming up from the bottom. And we'll start at the biggest index, and we're going to go up using a while loop, or we could use a for loop, I guess, and place a checker in the first open square that we find. And once we've placed a checker, we're going to break out of our for loop or our while loop. Otherwise, we're just going to be spamming checkers into the whole column. So we're going to start at whatever column they give us, and we're going to go to whatever column they give us, and we're going to start at the bottom, which means the biggest index, and go down, which means up, looking for a place to put the checker. And how do we know it's safe to put a checker there? Because there's a space in the grid at that coordinate. So let's go to drop checker here. And I guess I could do this with a for loop or a while loop. Let's try it with a for loop, I guess. For tab tab. What's our, how tall was our board? It was 7 tall, which means the biggest index is going to be 6. So let's say I starts at 6, and we'll go, as long as I is greater than or equal to 0, subtract 1 from I. So we're going to start at 6 and go down to 5, 4, 3, 2, 1, 0. And then inside of that, let's check to see is, I'll put enough comment here, creep up the board, creep up the column. There we go. Looking for a space. All right, that's what this code is actually doing right here. I'll put the comment there. All right, and then we can say if the board at, now what's our x coordinate? That's our column. What's our y coordinate? That's I. If that's equal to a space, well, now we've found a place to put the checker. So let's put a checker there. Well, what character do we put there? We've got a character called turn that we declared way up here. It's going to be an X or an O. So let's put our turn variable is now turn. So if the turn is an X, we put an X on the board. If turn is a Y, we put a, or if it's an X, put an X on the board. If it's an O, we put an O on the board. Okay, place the checker. And now let's flip the turn. So we can say if it's X's turn, now it's O's turn. Otherwise, it's X's turn. If turn is equal to X, turn is now equal to O. Whoops. Otherwise, turn is equal to X. So if you just have one statement, you don't actually need to do the whole full-blown parenthesis thing. It is correct. It's not incorrect to do that. However, if you just have one, this is for putting a group of statements together. If you just have one statement, you can skip the parentheses. And I'm doing that just to save space here, just so I can fit more on the screen. But it's good practice to use the curly braces. So if the turn was X's, now it's O's turn. Otherwise, it must have been O's turn, and now it's X's turn. Notice I've got the double equal sign for a comparison and the single equal sign for assignment. C# will not even let you do that. It should flag that as an error. You can see that it does. Okay, so let me put in a comment here. Switch the turn. And once we have dropped the checker and placed the turn, now we want to break. We're done. We've placed a checker. So stop looping. Break out of. So break jumps you out of one level of looping. So it'll jump us past the for loop, and that's that's it. That should be everything we need. So now we can just kind of connect all this stuff together. Let's go up to our run function here, and it draws the board. And now let's ask the player, for what column. Let's do console.writeLine, CW tab, enter a column, and then why can't I spell column? And then I'll say, maybe I'll put in a whose turn it is. It is turn. Okay, so how do I put in like a placeholder? The official way to do that, I mean, I could use a plus sign, but the kind of nice way to do it is you put in a placeholder. This is a placeholder for the first thing I put here. So turn is going to get substituted into that thing. If I had more than one thing, I could have curly brace 1 and then put in another thing at the end. Enter a column. Okay, and then you know what? Instead of doing right and line, I'll just do right, and that'll kind of keep things more compact on the screen. Okay, so now what I want to do is read in an integer. So I'll call it like int c, for column equals convert dot to int 32, and now let me read in dot read line. So if the player types in garbage, it'll blow up the program. We're not going to do any type checking here, and that's okay. I can live with it, or I'll show you how to fix it later, I guess. Or you know what I'll do, just to show you that it's the word try and then hit tab twice, and we'll do all our logic in here and then get rid of the throw. We don't want that, and then we'll just do cw.writeLine. Oh no, cw tab bad column. There we go. All right, so now we have the column, and now we can call drop checker C. So drop our checker into whatever column they specified. Or you know what? Maybe we want to check to see. Maybe we want to quit too. I don't. Okay, so let me just expand this a little bit. String s equals console.readline, and then maybe we'll check to see if s is equal to a q or something. Oops, how did weak reference? Break. No. Return. There we go. So that would bail us. Oh, no, wait. Break. Yeah, break will work. So you can see that I'm actually missing something in here. It's going to say that I can't break because I'm not inside of a loop. And that's a problem, right? Because this thing is going to run once, we drop a checker, and that's it. We want this whole thing to run repeatedly. So let's just put all of this in a while true. So I'm going to cut all my code here. Inside of my run statement, I'm going to say while true, and paste that in there. So now all my code is inside of this while loop. So this is just going to keep going around and around and around and around and around and around. So now I'm going to read in the console, and I'm going to say if it's a queue, then I'm going to break, and that's going to jump me out of this loop, and the program will quit. And then maybe say if they enter like an R for reset or something, maybe you want to play again. And notice I have double quotation marks. Double quotation marks indicate that this is a string. So when you read the console, you're reading in a bunch of characters. Double quotes are for a bunch of characters. Single quotes are for a single character. So what do we do if it's reset? Then let's say call our clear board function. And then let's continue. Continue means go back to the top of the loop. So we've now used break and we used continue. So continue means skip over anything after me and repeat the loop. So if we get down here, it wasn't a Q and it wasn't an R, and then we can convert S to a string. And maybe if there was like some trailing junk on there, you could trim it off. Trim gets rid of any white space, or we'll just assume people are entering the right stuff here. So convert the input to an integer and then drop a checker into that column. We could also check to see if the column is valid, right? Because -5 is an integer, right? So we could say if C is greater than or equal to 0 and C is, less than or equal to 7, right? Because our thing is 8 wide, which is 0, 1, 2, 3, 4, 5, 6, 7. Then drop the checker. Otherwise, it wouldn't do anything. So that's just a little safety check there. And that should be it. That should be all that we need. So if read the keyboard. If it's a Q, quit out of the game. If it's an R, we'll reset the game. Otherwise, convert whatever they typed into an integer. If it was a bad integer, we'll catch that. If it's valid, then we'll drop a checker in that column. And then maybe, in our run function up here at the very top, we'll do like, welcome to Connect 4. And then we'll say what the commands are. Q equals quit, R equals reset. All right, so let's run it and see what it does here. So there's our board. Welcome to Connect 4. Q equals R equals reset. All right, so it's X's turn. Enter a column, and then so right now we're here. We're waiting on this line. I'm going to put a breakpoint right after that, and we'll just see what happens here. So let me enter in a 6. Okay, so S is a character 6. It's a string with the number 6 in it, the character code for a 6. And we'll say, was that a Q? No, so we don't break. Is it an R? No, so we skip over this. So we'll convert it to an integer, and it's a 6. Is it between 0 and 7? Yes. So let's drop a checker into that column. So to step into that function, I'm going to hit F11, and now we're going to try to put a checker in that column. So we're going to start with I is 6. Is I at over 6? And what's over 6 down 6? Is that a space? Well, if you expand the board, you'll see the board is, oh, you know what? Look at that. Our board is all full of, the /0 means that it's a null. I mean, that is not the same as a space. Why? Why is that? Because we never actually called our clear board function. So where do we do that? Let's clear board. There we go. So when you create an array, the values have to, things in the array are given default values. And the default value for a character is a null. It's the character code 0. So I guess we could have used nulls for our board, but space made sense to me. So let's try this again. Kill it and start over. Okay, so it's X's turn. Enter a column. I'll say 3. Was it a Q? No. Was it an R? No. Okay, so convert S, the character, the string 3, to the number 3. Was that in range? Yes. So let's drop a checker in that column. We're going to drop a checker in column 3. So we're going to start at the board. We're going to go over 3. And our I is 6 right now because we set it to 6 in our loop. So is the board over 3, down 6? Is that a space? Well, let's look in our board. I'm going to expand this. You know that now you can see they're all spaces in here instead of nulls. And is that true? Yes. So we're going to put whatever is the turn, so that the turn is an X, and you can see the character code for an X is an 88. So it's going to take the character code for X and put it in the board 3 columns over and 6 rows down. And what's the turn? It is X's turn. So this is true, so we're going to do the next statement after it and set the turn to capital O. We do that, and then we break. So watch where we go when we break. Break means jump out of one level of looping. So here's our loop, our for loop. It's going to jump past this curly brace, right? See, now we're past the curly brace, and we're done. We've dropped our checker, and now we come around our while loop, and let's draw the board. And now notice it's O's turn now. And now we're waiting for input. So let's go check our console. You can see it dropped an X in the board. And then let me just remove the breakpoints so we can kind of see the thing run. So enter a column. I'll put it 7. And what? Shouldn't have stopped there. Okay. So you can see put an O there, and then let's put an O above it. And let's watch that in the let's watch what that does. Not in drop checker. Okay, so let's put a breakpoint and drop checker. And so now if I drop another O in column 7, what it should do is say, okay, hang on, the first one wasn't a space, so keep going, and put an X on top of that. So there's our program. So our column number is 7. Now let's look at the board. Let's go over 7 columns, and our I is 6 on the first pass through this loop. So what if we go into the board, over 7, down 6? What do we find? We find an O. Is that equal to a space? No. So we're going to skip over this code. And we're going to subtract 1 from I, and now I is 5. Is the board over 7, down 5? Is that a space? Well, yes it is, because there's no, we just saw that. Working from home is no picnic. All right, so what were we doing? We were dropping a checker into column 7, and the first spot that we looked at had a character in it that was not a space. So now we're trying to say, is the board over 7, down 5? What's there? Let's go figure that out. If I expand this array here, you can see over 7, down 5 is a space. So I'll put an X there. And now is the turn X? Yes. So now it's O's turn, and now we're done. And we come around again, and draw the board. And you can see now that I've placed a checker there. So let's just also test out that our quit and reset function works. So let me enter R and see what happens here. Okay, so now you see our program stopped on that breakpoint. Is our string that the player typed in, is that equal to an R? Yes. So we're going to clear the board and continue. So where do we go when we hit a continue statement? We're going to repeat whatever loop we're in. So we should come back to the top of this loop. So let's hit F10 and step through this and see what it does. You see it came back to the top of the loop. And so that's the difference. Break jumps you out of one level of looping. Continue skips, just teleports you back to the top. So those are two statements that are useful for working with loops. Controlling how whether you repeat a loop or whether you break out of a loop. And that's it. So now if I run this, you should see now the board's all clear again. It didn't really flip. It didn't flip the turn because we didn't tell it to. And then 0. What if I put in a bad column here? What if I put in 99? Oh, our breakpoint is still enabled. Let's get rid of our breakpoints. See, it didn't do anything. It just ignores it. What if I put in like some garbage? See, it says bad column and ignores it. We printed out bad column right there. So there's a Connect 4 game, very simple. You could put in win checking if you want, but I don't know to what extent people really are prepared to, if you don't have Visual Studio at home and you're doing this online, and the online compiler, that's going to be a little hard. So let's just kind of keep the program short. And there we go. But now you can find somebody to play this game with. It's a good exercise in loops, because we saw that we can use break and continue to control whether we jump out of a loop or whether we go back to the top of a loop. And also importantly, we learned how to work with two-dimensional arrays. So when you make a two-dimensional array, it's the type of thing you want to put in the array, followed by the square brackets and a comma to indicate that it's a two-dimensional array. Then you give your array a name, and then you have to allocate it. You have to carve out the space that array is going to point to. And so that's the new operator, followed by the type. These are always going to be the same, followed by the dimensions, 8 by 7 in our case. So hopefully that was, I know that was half an hour, maybe half an hour of your life you're never going to get back, or maybe that was an interesting little exercise in two-dimensional arrays and loop control. And it also shows you can make these fun little games. Without really much graphics and sound, you can still have a fair amount of fun on the computer. And then again, working from home is not a picnic. Find somebody to play this with, and then you'll also be well prepared for the submarine game, which is going to be very, very similar, very, very much based on a grid. So hopefully that was useful. If you have any questions, I would just say, as an activity, just type this in, see if you can get it to work, and then paste in your code as a solution. So, all right, thanks. Hope you guys are all doing well, and everybody's happy and healthy.